Okay, here's a quick video to help you understand what the heck Newton's method really is. It's possible to just jump in with a formula and go from that. There are lots of videos out there that show you how to do that. But I think it is really helpful to understand where these ideas generate these formulas. And it's really quite simple, because what we're saying is we're looking for this root, an approximation of the value of this root, some x value that gets us a 0 for our function. Well, if I pick a point, and the point needs to be close enough that it works. If this would have some crazy kink and you pick the wrong part of the kink, the tangent will send you off into outer space. But if I pick a decent point, and I pick a tangent, and I find the tangent along here, I can easily write the equation for a line in point-slope form that will give me the equation for this line using the slope of our tangent found with the derivative. And then I can just find a new x point, call that x2. And when I plug that into the original function, I'll get a value there that's x2, then f of x2, and then I can just repeat this by finding the tangent there, and you'll see I'm going to start getting really close really quickly, and that's the beauty of this whole system. So let's just backtrack to the original idea. I get an original guess point, a test point. I find the derivative at that test point, and then I use point-slope form to come up with the equation for this line, and I solve for the 0. So let's just do that. I'm going to use an example here. Well, I'll just do it generically. I'm going to say, okay, so I found from this point, I've got the slope here is going to be f prime of x1. That equals my slope, okay, which we would normally say, oh, that's our m. So remember, point-slope form is y minus y1. That's going to be equal to m times x minus x1, and these are our variables, x and y, and this is our fixed point. Well, our fixed point is right here. It's x sub 1 and then f of x sub 1. That's our fixed point. So this is going to be y minus f of x sub 1, and then that's going to be equal to our slope. Then remember, is f prime of x sub 1. Okay, that's what we just did up here. F prime of x sub 1 is our slope. And then that's going to be times our variable x, and then minus x1. Okay, well, let's just work with this. I'm interested in this point here, this x2. That's the 0. Well, that's when I find that magic x2, the y will be 0. So this drops out to 0. So I have 0 minus f of x1 equals f prime of x1 times x minus x1. All right, well, if I just divide both sides by f prime of x1, I get that over here, f prime, make sure that's the derivative at x1. I've now gotten rid of this, okay? And then I'm really interested in this x value. That's going to be my x2 value. So if I just then add x1 to both sides, what I get then is my very, very handy formula, which is x1. I'm going to just write it over here. x2 is going to be equal to, because there's my x2, x2 is going to be equal to x1 minus f of x1 over f prime of x1. Okay, so this is the handy dandy formula that is